Don't forget to subscribe and ring that bell.
Good morning, good morning. It is 7:58 a.m. and we're going to do some calculus. After we finish that first cup of coffee, that is. We are going to continue the 2012 AP Calculus AB practice exam. Free response question number 2. College Board put this out about a decade ago. And how do you like them apples, huh? We get to use a graphing calculator. A couple things. Subscribe, okay? That helps you. You will get notifications when I put up more videos. And like this video, because that helps me, all right? And while you're down there ringing that bell, in the comments, if you want to see something done, throw a test year out there. I'll try and get that. I will definitely take requests. Also, I keep on saying this. I use a TI 84 Plus CE calculators. I put a slew of links in the descriptions because, who likes just basic gray sometimes or black sometimes? So that school yellow color is god-awful. Ton of colors. So there are a ton of links down there. I personally like and own the mint green one. I love it. Okay, let's get started with free response question 2. Let's go. You know how I can tell it's a beautiful morning? Because we automatically start with a graph for problem 2. Let R be the region in the first quadrant bounded by the x-axis, the graphs of y equals ln of x, and y equals 5 minus x, as shown in the figure above. Find that area of R. Let's set this bad boy up, shall we? Okay, the area of R is all of this under the curve. Woo! Look at all that R. All right, we're going to go here. I love me the calligraphy pen. The x-axis, in case you didn't know, is this right here. That's the x-axis. And then we have 5 minus x. That's the straight line here. Okay, that's the straight line of y equals 5 minus x. And then we have this ln of x, which is kind of curved graph right here. Y equals ln of x. All right, so we need to find the area of R. And area under the curve is the integration. All right, here's the problem. Okay, I got to find the integration underneath 2 separate curves and add them together. You see this point of intersection right here? Here's 1, 2, 3, 4, and 5. Okay, I want my bounds to be between 1 and 5. However, I'll call this area 1 and this area 2. Okay, area 1, okay, is going to be the integration from 1 to this value, which I don't know yet. I'm just going to put a question mark up here. And that's the area underneath the green line, the ln of x. Don't forget your dummy variable, the x. I need to add that to the area of 2, which is the integration from some value I don't know yet to 5. And that equation is the red line. That's the area under that curve or function, so to speak. 5 minus x, our dummy variable dx. So the one thing that's really ultra important is we need to figure out what this value is right here, because it's going to be the upper bound and the lower bound. All right? So because we got that wonderful TI 84 Plus CE in our hand, yeah, I know, guys, I know. I am going to graph this, and I am going to use my intersection function and see where that intersection occurs. So y equals, what do we have? We have red and green. Awesome. So I'm actually going to use the red and green curve. The red curve is my 5 minus x, and the green is the ln of x. And let's see what our bounds are. Okay, that's from 1 to, we'll go from 0 to 5 on the x-axis. What about the y-axis? Oh, let's just go up to 2. Okay, so I'm going to make my window just like the picture they gave me. So x is going to go from 0 to 5. And my y is going to go 0 to 2. Let's graph this. So we should have a very, very, very good, there's 5 minus x. And here's the ln of x. Okay, I got to stretch it and change it a little bit, but it's really good, right? I want this intersection point right here. What is this value? That's what I'm trying to find out. And in order to do that, second, trace, and I pick intersect. And I live my little spider dudes at 2.5. Oh, it's on the red. Let's bring it down to the green curve. And go just close enough to the intersection. Doesn't have to be right on it. Hit enter 3 times. Bang, bang, bang. And you'll see at the bottom, x is 3.693. Okay? So what I'm going to do, okay, that is stored in the x, okay, in the x variable. But when I use the integration function in the calculator, and I have my x variables in there, I don't like to put x as a bound. I'm sure it's fine. I'm just going to store this in a, just so I can have 2 variables. One will actually be the number, and one will actually be the variable that could be anything, could change. That's the x. Okay, so let's call it 3.69 for the sake of writing it on our paper here. This is 3.69, which means up here is 3.69, and down here is 3.69. So all I've got to do at this point is put this in the calculator just like this. Of course, I don't want to round my 3.69. I only want to round when I get my answer. So in for 3.69 in the calculator, I'm going to put that a, because that's the variable that I assigned my value to, if that makes sense. So let's go here, let's go here, let's go here, let's go here. I need the integration, math 9, from 0 to a, because that's where I put 3.693441359. I could type it all out if I want. Not going to do it, but I could. Okay, and that's the ln of x. Now, that's why the reason I put that in a is because I don't like to put an x here and then put ln of x. Yep, I don't know what is. Oh, there you go. ln of x dx. I don't know. Maybe it's an OCD thing for me. I just don't like that. So I'm just going to make that a, so I know it's definitely different than the variable here. It's assigned 3.69, whatever. Okay, I'm going to take that. Ooh, I have 2 opening parentheses. I need 2 closing parentheses. I'm going to add that to the integration, math 9, of 3.69344. But hey, I stored that in a, so I'm going to type it up. To 5 of 5 minus x, dummy variable dx. There you go. I use the calculator to find my intersection point, and then I put that as the upper bound for that first integration and the lower bound for the second integration. And as I went over that, if you didn't see I made a boo-boo here, it's not from 0, it's from 1. So hit enter. 2.98, we will round. Okay, now we can round. This is our final answer. That's going to go through a 6 because the number after it is 5 or bigger. 2.986. There you go. That wasn't that bad. The explanation, which is what you're here to see, is what takes so long. If you know what you're doing, that takes 2 seconds. Find the intersection points, put it in the calculator with your integrals. 2b. Region R is the base of a solid. Ooh. For the solid, each cross-section perpendicular to the x-axis is a square. All right. So, again, we have our 5 minus x. We have our ln of x. And now they say we have these squares. Okay, calligraphy pen. Of course I'm going to use a calligraphy pen. Great. We have squares, which means from here to here, it's a square. Okay, each section is a square. Okay, I know I'm drawing, it looks like rectangles. But then right here, it's a square as well. Right here, it's a square as well, and so forth. Keeping in mind that it's still the split point is 3.69 dot, 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 dot. All right? So now I need to find the volume of this shape of squares all jammed together underneath this curve. Now, anytime I want volume of the base, okay, for the solid, okay, for R, for region R, which is the area under the curve, right? This is the area under curve. But now they want the volume. Yep, I should spell that right. Volume under the curve. And the volume is a stack of squares. Anytime I want volume under that curve, I'm going to integrate the area of the shape. In this case, it's a square. The area of a square is, I take the side and I square it. I integrate the side squared ds. Okay, what is the side? Okay, the side, first of all, if it's a square, all the sides are the same. And the length of each side is from here to here. So it's this distance. Okay, so when I'm underneath this green curve, my side is the ln of x. When I'm underneath this red curve, my side is 5 minus x. So I still got to do this with two separate integrations that I add up. The volume for this area, 1, and the volume for the right side, which is 2. Okay, so let's break that up right now. All right, so I'm going to integrate. Okay, this is volume of 1. Okay, my side is just the ln of x. But let's not forget, I got to square that. That's the side squared, dx. From 1, oh boy, for poops and giggles, because they are, I mean, should I write this whole thing? On my answer key, I wrote this whole number right here. I suppose I could put 3.693. I'm gonna write everything. 4. Oh my God. So let's do this. Bring this out here just so I can see it once. And get rid of this. $3.693441359. Okay, that's that volume of that first area plus the integration from 3.693441359 to 5 of the other side squared. The other side is 5 minus x dx. Now, the great thing about this problem is, and I'm not even sure we finished reading it because I saw volume and square and I got excited. Sorry, didn't mean to get excited, guys. Is the following. Write, but do not evaluate an expression involving one or more integrals that gives us the volume. That's what we just did. We're done. Right, but do not evaluate. Right there. I mean, we could evaluate. This is a calculator problem. Could have easily put that in a calculator. That's an expression. There's no equal sign. It's fine. I don't got to put volume equals. That's perfect. 2C. And just like 1, there's only 3 parts. There's not a D, a 4th part. So it's just A, B, and C. There was 1 A, B, and C. There's 2 A, B, and C. I tell you what, this 2012 exam, they got a couple breaks here. Anyways, 2C states the horizontal line y equals k, not x equals k. It's not a vertical line. It is a horizontal line. Keep that in mind. That will come back to play. Divides R into 2 regions of equal area. All right, so write, but do not solve an equation involving one or more integrals whose solution gives the value of k. So I'm going to set up an expression, or an equation rather, that would help me solve for K. So right now, I have got, and I'll do this in orange. Okay, I've got this, before I even do that, I've got this area. This is our yellow area here. I want to divide that in half, but I don't want to divide it in half vertically. I don't want this cutting it in half. No, 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 no. I want to cut in half this way. Okay, and don't think that this is just 0.5. No, whatever this area is, I want that, half it. So I want half of my area up here and half of my area here. Actually, it looks like this line probably should drop down a little bit. It looks like it might be lower than a half. But anyways, I'm just guessing here. Let's do the math and set it up. And we don't have to figure out what K is. We just got to write an expression, or an equation, excuse me, that would help us figure out what K is. Okay, so I'm going to have an equation. It's going to have K in there, and that should be the only unknown. All right, now let's keep in mind my red line is 5 minus x. My green line here is ln of x. All right, now here's the thing. Here's the thing. All right. Oh, and let's label this K. But this is y equals K. It's y equals K. How do I explain this? I need an integral. Okay, I need an integral. All right. But notice, horizontal line, my bounds are not going to be here from 1 to 5 or whatever, or 1 to 3.69. Those are not my bounds anymore. It's not vertical. It's horizontal. My lower bound, okay, can be y equals 0. And my upper bound is K, right? So I'm really going to try and find the area of this bottom half. Okay? All right. So if my bounds are y equals instead of x equals, I don't want to say ln of x or 5 minus x here. If my bounds are y's, the variables in my expressions, in my integral, should also be y's, not x's. So look at the two equations I have. I have y equals 5 minus x, and I have y equals ln of x. I was putting these into my integrals. I want to change them so they're x equals something with a y on this side, and that's what I want in my integral. Same thing here for this one, okay? So that's exactly what we're going to do. We're going to change our equations so that they're x equals and our y is in the expression that's going to go into our integral. All right, let me go ahead and do this. If I got y equals 5 minus x, let's add x to this side and subtract y from this side. I got x equals 5 minus y. Okay, this is going to be the expression five minus y, okay? And that will now be, I'll change it to a blue line. Okay, and let's go with a purple. If I got y equals ln of x, I'm going to take both of these to a base e and say e to the y equals x. So this equation here is now going to be e to the y. That's this line right here now. All right. Now keep in mind, all right, if I want the area of just this green, okay, and why am I doing that? Because I'm going to set my equation equal to half the area. all right? I'm going to do the bigger minus the smaller. The bigger one is the one that's further away. The bigger expression is the blue one. So it's going to be 5 minus y, because that's the bigger one, minus the smaller one, which is e to the y. Bigger minus smaller, dy. Okay, let me go over this point. And you don't see this on the exam that often. So I said 2012 got a kind of a break because they're doing less work, but you don't see this that often on the exam. And let me state this one last time. If my bounds are y's, not only do my expression needs y's, my dummy variable should be a y. Okay? So this will give me the area under the curve from 0 to k. Okay, and they said k should split the area exactly in half, shouldn't it? It should. It should split this exactly in half. So when I set that equal to something, if I look at part A, what was the area under the curve? 2.986. I don't want that equal to 2.986. This should represent half, right? K should split it in half, so it's 1/2 times that. Now I have a legit, this is the thicker one, expression where I can solve for K if I need to. All right, that's it. That expression, I keep saying expression because part B. This is an equation because there's an equal sign. I have an equation right here where I take my integral, I set it equal to half of that area, and I could definitely solve for K. Again, write, but do not solve. That's fantastic. I love it. All right, there was a lot of talking. Subscribe. Like the video. And if you're in the market for a calculator, throw those, take a look. You don't have to buy one. I'm not putting it up there because I'm desperate or anything. But I've gotten a lot of questions about the calculators I use. I have a class set that I personally fundraised for or was donated to me by. And they are not just the TI-84 pluses. They are the TI-84 plus Cs. They're the yellow and gray school-colored ones, which I don't like. I wish I could have had a set of rainbow-colored ones. That'd be cool, all different colors, but I don't. Okay, so subscribe, like the video. Those are the important things. And guess what? Veterans Day is tomorrow, so have a great 3-day weekend. And be on the lookout for more videos by Visca the Teacher. Bye-bye.
Don't forget to subscribe and ring that bell.